about R1. So we have to make sure that we get all the way back to R1, which is 3 feet. Okay? That's far and away the most common mistake where people get tripped up on this. Is they'll drop it at that midpoint and they'll think, well, it's 2 feet away from the midpoint, I'm going to multiply it by 2 feet. Okay? Make sure that you get all the way back to the reaction. Okay? What about the 600 pounds? How far away is 600 pounds? 7 feet away. And then we have R2, 10 feet away, and R2 is going to be negative, right? If our convention is that positive rotate, or sorry, clockwise rotation is positive. So 10 R2 pound-feet equals 5,400 pound-feet, right? 1,200, 4,200. Everybody's buying what I'm selling? Okay. So what does that mean for R1? If R2 is 540 pounds, what's R1?
460.
460 pounds. Does that physically make sense when we look at the span? Should R2 be picking up more of the load?
Yeah.
Seems reasonable, right? We got 600 pounds, 3 feet away. Over here we've got 100 pounds per foot, so we're going to have a lower total magnitude over on that left-hand side. So makes sense that we would have less load picked up at that reaction. Okay? So now let's look at the shear diagram. So, what happens when we get just to the right of R1? Not even a half an inch. We just thought about taking a step off of R1. What's the shear? 460. 460. Okay? Does anything change over the first foot? No other applied forces, right? So there's going to be no change in our shear. So what happens here?
I think it's 100 pounds per foot.
Okay.
So it would drop, it would step down.
Okay, and we just have to be careful that we aren't going to make steps down, right? We're going to make a continuous drop of 100 pounds per foot over 4 foot, okay? And the reason being is if we start thinking of it as, well, I'm just going to drop 100 pounds per foot until I get there, okay, but now you have to think about it, because that's not truly what occurs, because I could also write this as 8 pounds per inch, right? So now you've got to drop 8 pounds per inch, right? But it's really 4 pounds per half inch. So now you got to write it 4 pounds per half inch. Or it's 2 pounds per quarter inch. Or 1 pound per eighth inch, right? And pretty soon we're doing calculus, because we're taking infinitesimally small values and differentiating them. Okay, that's all that calculus is. But instead, if we just draw a nice smooth line, dropping 100 pounds a foot, so what we're saying, there's 5 foot. Okay, how much total drop are we going to have?
400.
It's going to drop a total of 400 pounds, right? So we're going to be down here at 60 pounds. Okay? Then what happens? For the next 2 feet, are there any changes? No changes made, right? What do we do once we get just to the right of our 600-pound force? We're going to drop down 600 pounds to minus 540. Right? And then we run across, bring it back up. Okay? So what does your Vmax look like this time?
540.
540 pounds, right? Because when we take the absolute value of that, that's going to be larger than your 460. Very good. And where does our shear equal 0? Sorry, where does our, at non-reaction points, where does shear equal 0? 3 foot from R2, okay? Questions? So, big thing to remember with your shear diagrams. Point loads are going to correspond to these drops. Okay? They're occurring instantaneously. Uniformly distributed loads, we need to give them constant rates of change in the shear. Okay? Those are the only types that you're going to see. I'm not going to give you anything that's going to give you a polynomial or trinomial or anything odd. We're not going to take into account other dimensions. Okay? Cool? So tackle those. Come back with questions on Thursday. If there aren't any questions, we're going to jump from shear and we're just going to add on bending. Okay, that's the only thing that we do at bending, where it's the same thing. We'll set them up where we determine static equilibrium. We determine and draw our shear, and then we go over the beam again, but rather than just looking at how the forces interact in the y direction, we look at how they cause rotation as we move across the beam span. Okay? That'll be the last major general concept that we talk about. Then we'll start looking into how do we size and select materials based on loading sequences. Okay? Cool. Take a look at the terminology quiz. I think I gave it until Sunday. Maybe it's next Tuesday. I forget.
I think it's